So here's some notes and examples on Descartes' rule of signs. Let p of x be a simplified polynomial with real coefficients. Now remember, the coefficients are the numbers in front of the variable, so the coefficient here would be 2, -3, 2, -3, 1, -1. Okay, so those are the coefficients, the numbers in front of the variables. So this is our polynomial of x. It's a simplified polynomial with real coefficients, and the terms arranged in descending degree of x. So here's descending degree. In other words, this is the 8th power or 8th degree, 6, 5, 4, 2, 1. You don't have to have all the powers. We're missing in this case a 7, and I guess a 3, but you have to have what the powers you have must be in descending order. Okay, so these are the parameters. Then we have two situations as far as telling us the number of positive roots we have. So number one, I'll give you some examples. The number of positive real roots of p of 0, or p of x equals 0, equals the number of variations of sign, that sign changes, of p of x, or is fewer than this number by an even integer. So here's an example of what we mean. So here's a polynomial, and we check. We have descending powers. Okay? And these are real coefficients. The coefficients are real numbers, not imaginary numbers, or i's, things like that, or 2i, stuff like that. Those are imaginary numbers. These are real numbers. And if we look at the sign changes, in other words, when the signs change from positive to negative or negative to positive, well, at the beginning, this is understood to be a positive. We don't see something in front of it that's understood to be positive. So it looks like we have a sign change here from positive to negative, so there's a change. There's another one from negative to positive. There's not one from positive to positive, but there's another one from positive to negative. Not one from negative to negative, that stays the same. Another one from negative to positive. So this is where my signs are changing, and positive and positive. So how many sign changes do I see? 1, 2, 3, 4. 1, 2, 3, 4. So that's the number of positive real roots we have is 4. So you say there are 4, or an even integer 2 less than 4, which is 2. And what's another even integer less than 4? 4, or just subtract another 2 and we get 0, or 0. So there are 4 or 2 or 0 positive real roots. And that's all there is to it. So look at the sign changes, and then just keep subtracting 2 till you get to 0. Or -1, then we stop at 0. Okay, here's another example. So again, we're in descending powers. 7, 5, 4, 3, 2, 1, none. And these are all real coefficients, 2, -3, etc. And again, this first sign is understood to be positive, so we've got a sign change from positive to negative. No sign change there, but another sign change from negative to positive. No sign change there, and then another sign change from positive to negative, and no sign change there. So how many sign changes do you see? 1, 2, 3. Positive to negative, negative to positive, positive to negative. So there are, there are 3, or, and what's 2 less than 3? 1. And 2 less than 1 is -1, so we pass 0, so we stop. So there are 3 or 1 positive real roots. Okay. So that's not too bad. Let's take a look at one more example. And this is p of x is 3, x to the 6th, x to the 5th. And then look at our powers. We're going 6, 5, 4, 3, 2, 1, none. So we're in descending powers. All my coefficients are real numbers. So I look for my sign changes, and again, this first sign is understood to be positive, just like this one is understood to be positive. So I'm going from positive to negative, so that's a sign change. So I got one sign change there. Negative to positive, sign change there. Positive to negative, another sign change there. No sign change there, negative to negative, but a sign change from negative to positive and from positive to negative. So how many sign changes do I see? 1, 2, 3, 4, 5. 5 sign changes. So we could say there are. And I say 5, or, and what's 2 less than 5? 3, or what's 2 less than 3? 1. And then I pass 0, so I'm done. Positive, real roots. So there you go. All right, so that's the first part. We have another part, and I'll do that on the next video. So make sure you watch the second video on these.